In this video, you'll get an introduction to parabolas. A parabola is the graph of a quadratic function. So if you remember from previous sections, a quadratic function is a second-degree polynomial. So it would look something like f of x equals ax squared plus bx plus c, or y equals a times the quantity x minus h quantity squared plus k. Both of these are examples of quadratic functions because the leading term is ax squared. Now we have a few rules about the leading coefficient. Remember, the leading coefficient is the number in front of the squared term when we're talking about a quadratic. So in both of these cases, a is my leading coefficient. So if the leading coefficient is positive, then the parabola is going to open upward. So it would look something like this. If the leading coefficient is negative, then the parabola is going to open downward. And so it would look something like this. These are the basic shapes of parabolas. They can get skinnier or wider, and they can shift up and down depending on what numbers you have for A, B, and C, or for A, H, and K. To find the x-intercepts of a parabola, let y equal 0 and then solve for x. And to find the y-intercept, let x equal 0 and then solve for y. This is true for any function that you have. This would be the method that you use to find the intercepts. A quick reminder, an x-intercept is where the graph crosses the x-axis. And so with a parabola, you could either have 0, 1, or 2 x-intercepts. In this example that I've put up, there are 2 x-intercepts because the parabola crosses the x-axis at 2 points. There will always be at most 1 y-intercept. Otherwise, you wouldn't have a function. And we know that quadratics are functions, and so you'll have 1 y-intercept. The turning point of the parabola is called the vertex. If you're given the quadratic function in the form f of x equals ax squared plus bx plus c, then the vertex is the ordered pair with x equal to negative b over 2a and y equal to f of negative b over 2a. So you find the x value of the vertex first, then you take that value, plug it into your original function, and that will give you the y value of the vertex. Given a quadratic in vertex form, which is y equals a times the quantity x minus h quantity squared plus k, the vertex is the ordered pair hk. Notice that h, the x value of the vertex, will have the opposite sign of what you see in the function, and k, the y value of the vertex, will have the same sign as what you see in your function. The vertex will be an absolute minimum if the parabola opens upward. So here's an example. Here's an upward opening parabola. The vertex is at the point hk, and it would be a minimum on that graph because all the other y values on the graph are larger. The vertex will be an absolute maximum if the parabola opens downward. So here's an example of a downward facing parabola. The vertex is at the point hk, and that's going to be the highest y value on your graph. Remember, the parabola opens upward if the leading coefficient is positive, and downward if the leading coefficient is negative. The axis of symmetry is the vertical line running through the vertex. The equation of the axis of symmetry is x equals negative b over 2a. So basically the x value of the vertex. So here's a couple examples. We have the downward facing parabola. The vertex is the highest point. The y-intercept is where your graph crosses the y-axis. The x-intercepts are where your graph crosses the x-axis, and your axis of symmetry is that dotted line that goes through the vertex vertically. For an upward-facing parabola, this would be when the leading coefficient is positive. Your vertex is the lowest point on the graph. Your y-intercept is where your graph crosses the y-axis, and your x-intercepts are where the graph crosses the x-axis. Your axis of symmetry is this vertical line that goes through the vertex. Let's do a practice problem. We want to find the x-intercepts and coordinates of the vertex for the parabola y equals negative x squared minus 2x plus 8. All right, so let me start with the x-intercepts. Remember, to find the x-intercepts, what you want to do is let y equal 0 and then solve for x. So for the x-intercepts, I have to let y equal 0. Okay, so my function then becomes 0 equals negative x squared minus 2x plus 8. And I could solve this with any of the methods that I learned in previous homework sections. So I could use the quadratic formula, or I could go ahead and factor it. This one looks fairly easy to factor, so I'm going to go ahead and pull out the negative first, and then I'll have x squared plus 2x minus 8. And I want two numbers that multiply to be negative 8, but add to be a positive 2. So I'll have x, if I do a plus 4 and an x minus 2, that should give me x squared plus 2x minus 8. Let's double check using a box to multiply. Okay, so here's my box. I have x plus 4. And then on the other side, I have x minus 2. In this first box, x times x gives me x squared. Second box, I have 4 times x would give me 4x. In the third box, I have negative 2 times x, so minus 2x. And then in my fourth box, I have positive 4 and negative 2 gives me a minus 8. So when I add my like terms, 4 minus 2, I get the plus 2x. So I've checked to make sure that I've factored correctly by multiplying it out. So now I use the zero factor property that says if I have two things multiplied together, then I can set the first one equal to 0. And this only works if your equation equals 0, which it does in this case. So I'll have x plus 4 equals 0 and x minus 2 equals 0. Then go through and solve. This would be x equals negative 4 because I have to move that 4 over to the other side. And x equals positive 2 because I would have to add 2 to both sides in order to get the x by itself. So that will give me my two x-intercepts. I would, if I wanted to answer as ordered pairs, I would say negative 4, 0 and positive 2, 0. Those are my ordered pairs that are the x-intercepts. If they just want the x values, you would enter negative 4 and positive 2. All right, now the other thing that we're asked for is the vertex. So remember, to get the vertex, we're going to let x equal negative b over 2a. And what I have to do is identify my a, b, and c. A is the number in front of the squared term. So I have a is negative 1. B is the number in front of the x term. So b is going to be negative 2. And then c is the number added or subtracted on. So this is c equals a positive 8. So first, identify your a, b, and c. And then you can plug it in. So x equals negative b, which would be negative negative 2 over 2a. So that's going to be over 2 times negative 1. And that would give me a positive 2 over a negative 2. So the x value of the vertex is negative 1. And then the y is going to be the value that I get when I plug negative 1 in for x. So I'll get negative and then negative 1 quantity squared minus 2 times negative 1 plus 8. And you can just work this through. We're going to get negative 1 squared is a positive 1, and then we have that negative out front. So we'll get negative 1, negative times negative is positive, so plus 2, and then plus 8. That would give me 9. And so then my vertex is going to be at the point x equals negative 1, y equals 9. You can check this by graphing the parabola in Desmos. Just put in y equals negative x squared minus 2x plus 8 and make sure that you get the same x-intercepts and vertex. However, make sure you are able to show your work on the test because you do have to show work in order to get the points. So negative x squared minus 2x plus 8. All right, so I've got my graph here. My x-intercepts are negative 4, 0 and positive 2, 0. Let's double check. That's what we got. Negative 4 and positive 2. And the vertex is up here at this point. And I can see from the grid that's going to be at negative 1 for x and a positive 9 for y, which is what I got. So you may check your answers using Desmos, but make sure you are able to show the work for the x-intercepts by letting y equal 0 and solving for x, and show your work for the vertex by using the formula x equals negative b over 2a, and then y is from plugging that value into your function. Let's do one more example where we are given the graph and we are trying to find the vertex, the x-intercepts, the y-intercept, and the equation of the axis of symmetry for the parabolas. We also need to answer, is the leading coefficient positive or negative? So first of all, the axis of symmetry, I know that's going to be the vertical line that goes through the point of the vertex. So let me just draw that in on both of my graphs. There's the axis of symmetry for the first graph. Here's the vertex of the second graph. And there's my axis of symmetry. So coming back to this first graph, the upward facing parabola, we have the axis of symmetry is going to be x equals 2, because you can see that 2 is the value of x at the vertex. So for our axis of symmetry, we'll have x equal to. And over here on the downward facing parabola, we have our axis of symmetry, this vertical line through the vertex. You want to look at the x value. The x value is 3. So the axis of symmetry is going to be x equals 3. Now let's look at the x-intercepts. So for this first graph, the x-intercept is going to be where our graph crosses the x-axis. And so our x-intercepts are going to be -4 and 8. So for the x-intercepts, I'll abbreviate it x-int, we're going to have -40 and 80. Over on this right-hand graph, we can see that the graph never actually crosses the x-axis. So over here, we would have no x-intercepts. For the y-intercept, we're looking for where the graph crosses the y-axis. So on the y-axis, we can see the graph is going through at y equals -8. So our y-intercept is going to be when x is 0 and y is -8. Over here on the downward facing parabola, it looks like the graph is crossing the y-intercept at -5. And so we would have a y-intercept at the point 0, -5. And the other thing we need is the vertex and whether the leading coefficient is positive or negative. So the vertex is the turning point. So this is going to give us the vertex. We need an x value and a y value. So as an ordered pair, this would be x equals 2 and y equals -9. So 2, -9 for the vertex. And here the vertex, the turning point is at 3, -1. So the vertex, in this case, which is a maximum, I'm going to have x equals 3 and y equals -1. So there's my ordered pair. And then you want to think about the leading coefficient. This graph opens upward. So it's going to have a positive leading coefficient. Over here, this graph opens downward, so it will have a negative leading coefficient. So that's an introduction to parabolas. We'll go further in the next video and actually graph some parabolas when we're just given their equation.